Calculus and welcome to 4.3. This is the chain rule, a little bit more to this one. So we're going to start off without derivatives just so you remember how to do compositions. Then once you have compositions down, then we're going to move into the derivative of the composition. So you should have 4.3 notes out, should say chain rule on the top. Let's go. So right here, when you look at compositions, that means you start with an x or a value, you plug it into a function, you get that answer back, which is the y of that value, but that becomes the x of the next function that you plug it in, all right, which gives you the next value. This is read g of f of x. Now, let's do this with a couple of functions. So we've got 2x plus 7 for f of x, and g of x is the square root of x plus 1. If I want to do f of g of 3 is how that's read. This one's easy because it has a number. You take the 3 and you actually plug it into the g. So I take g right here. I plug the 3 in, so the square root of 4 is 2. I take that answer. So since this equals 2, we plug the 2 into the function of f. So now we do f of 2. So now we're plugging it into this one. So it's 2 times 2 plus 7. So the entire answer is 11. All right, pause and do yours. Okay, I hope you had trouble with that one. Because now, when you plugged in -5 plus 1, your answer was the square root of -4. Square root of -4 is 2i. 2i is imaginary, therefore it is not in the domain, and this function is not possible. It doesn't exist. All right, so now let's do this when there's only functions and no numbers. So if I say f of g of x, that means since there is no number for the x, I plug the entire function g into f. So the entire function g was the square root of x plus 1. I replace the x in the f, because remember this was 2x plus 7. So I take this x out and I replace it with what g is worth. And that's the answer. Okay, I would like you to use the same functions we have above. I want you to find g of f of 1 and g of f of x. All right, when you plugged the 1 into the f, so you were taking 2 times 1 plus 7, and you got 9. So then your next step was to plug the 9 into g. So now you're finding g of 9 is what you're finding. So when you plug the 9 in, sorry, you should have had the square root of 9 plus 1, which was the square root of 10. This time we're taking the function f and plugging the entire function into g. So we know that g is the square root, so we're going to take the square root. All right, your x now becomes your f of x, which is the 2x plus 7. So you take out the x, you replace it with the 2x plus 7, plus your 1. So your entire function then is just 2x plus 8, and nothing else can be done. I hope you did well with that. Composition, that's old, but it's been a while since we've talked about it. Okay, now we're going to go backwards. We want to write the function. So this is my composition function right here. We've already done all the work. I want to undo it. So to undo it, I look at what's inside the parentheses or the grouping symbol. And since they are both 3x plus 4, I'm going to make that a function. So g of x is now 3x plus 4. So wherever 3x plus 4 is in my original function, I'm going to take this out and replace them with x. So now that's 2x squared minus x, and that is my second function, f of x. Now to get h of x, I need to plug g into f. So it's f of g of x. You can rewrite it any way you want to. Okay, pause and do yours. So let's say you let f of x equal to x minus 5. Then your g of x would have equaled the square root of x plus x, because you took the x minus 5 out in both cases. Then your h of x is a composition of those two functions, which means f goes into g this time. So that's g of f of x. Okay, composition. Quick reminders what that was. All right, now we want to do the derivative called the chain rule. Okay, we do the chain rule when we can't do them each individually, when there's too much. All right, so I have a function inside of a function is what's happening. So right here, if you look at this one, there's a 3x minus 5x to a power. So I've got a function inside of a function is what's going on. So to do the chain rule, so the derivative of y with respect to x, we kind of make it up. We go the derivative of y with respect to u, and then the derivative of u with respect to x, because these derivatives will cancel, giving my derivative. Later on, you may be able to start to do all of this in your head without showing the work, and that's fine. But right now, we're going to show the work so we understand what's going on. So the first thing we're going to do is we're going to let this inside be my function u. All right? That means my composition then is u to the 1/2 power. Good to this point. So now I have to define the derivative of y with respect to u. So I'm doing this one, the derivative of y with respect to u. So that's just 1/2 u to the negative 1/2, right? And rewritten, the 2 is in the bottom, and u to the 1/2 goes to the denominator. Now I have to do the derivative of u with respect to x. So that's just 6x minus 5. Good to this point? Now we multiply those two. So we got this derivative times this derivative, but I don't want the u there. So I'm going to take the u out and replace it with what it was originally worth. So this u now becomes 3x squared minus 5x. Now we just do the math. So we multiply the numerator, multiply the denominator, nothing cancels, so we are finished. Okay, let's try it again. Inside becomes the u, x squared plus 5x. Take that out, and it's u to the 8th. So now I have to do the derivative of u with respect, our derivative of y with respect to u, 8u to the 7th. The derivative of u with respect to x, which is 2x plus 5. Multiply these two derivatives together. Replace u with its original, which is x squared plus 5x. Got it? So step 1 is u, find u. Step 2, you write y, as a function of u. Step 3, you find the derivatives of both, of y and u. Step 4, you multiply them. Step 5, you replace, u with original value. Okay, I hope that helps. All right, try yours. Pause and give this a shot. Step 1, u is x squared minus 7, y is u to the 10th. Step 2, derivatives of both. So I know the derivative of u with respect to x is 2x. The derivative of y with respect to u is 10u to the 9th. Step 3, we multiply them together. So I'm trying to find the derivative of y with respect to x. So to do that, that's 2x times 10u to the 9th, but I cannot have that u, so I must replace it with what it is worth. So that's 2x times 10 x squared minus 7 to the 9th power. Whoops, that's a 9. And we can actually do this math right here, so we need to do that. So that's 20x, x squared minus 7 to the 9th power. Is it making sense? Just follow your steps, you'll be fine. There's nothing too major. All right, this guy's a little bit mean because now I'm multiplying two functions and I have a function in a function. So I need to do both rules. Before I start, I have to be able to find the derivative of 3x plus 5 to the 5th. So this is where we're starting. So we know u is 3x plus 5. We know y is u to the 5th. So the derivative of y with respect to u, remember step 2, is 4 or 5u to the 4th. Derivative of u is 3. Okay, now we multiply these together. So that we're really doing 5u to the 4th times 3. Then I have to replace the u with its original, which is 3x plus 5 to the 4th. Final answer is 15 times 3x plus 5 to the 4th power. Okay, that is just the derivative of the second part. So now we have to use our product rule. So we take the derivative of the second. I don't know why I didn't put 15 right there. All right, derivative of the second times the first plus the derivative of the first times the second. Good to this point. Now we're just doing our math. So here, oh, I see what I did. I was trying to help us out here. When you look at this, what do they both have in common? This guy has a 3x plus 5 to the 4th, and this guy has a 3x plus 5 to the 5th, which means they have a 3x plus 5 to the 4th in common. So I'm going to take that out. They also have a 4 in common. So I'm factoring out 4, 3x plus 5 to the 4th. That is our greatest common factor, is 4 times 3x plus 5 to the 4th power. So if I take it out of this guy, the 4 is gone, 3x plus 5 is gone. So now we're left with 15x, which is where this came from. Now let's go to this side. I'm taking out the 4. I'm taking out 4 of these, leaving me with 1, 3x plus 5. So that's where this comes from. Combine your like terms, and you're done. All right, try yours. Pause and give it a shot. Okay, step 1, your two factors. So this one here is a double one, so we got to find the derivative of him first. So the derivative, let's just write him a little different, cubed. So to do this, we know u is equal to 5x minus 1. That means y is going to equal to u cubed. The derivative of u with respect to x is 5. The derivative of y with respect to u is 3u squared. We need to multiply those together. So the derivative of y with respect to x then is 5 times 3u squared. But I got to replace the u with its original. So this is 5 times 3 times 5x minus 1 quantity squared, which gives us 15 times 5x minus 1 squared. That is the derivative of the second. So now let's use our product rule. So we know the derivative of y with respect to x is equal to the derivative of the first, which is 2x times the second, 5x minus 1 cubed, plus the derivative of the second, which is 15 times 5x minus 1 squared, times the first, which is just x squared. All right, now let's see if we can simplify this thing. What do they have in common? And we look at this, we've got 5x minus 1 squared. And if you look here, I have an x here and an x squared here. So here and here, I have an x in common. I have a 5x minus 1 squared in common, and that's all we have. So now what's left, if I take out the x and the 5x minus 1 squared, I will have 2 times 5x minus 1 plus, now here I took out an x, only one x, 5x minus 1, 15x. Okay, let's combine here. So we've got 10x minus 2. So our final answer is x times 5x minus 1 squared times 25x minus 2. I hope you did a good job. All right, next on the list, quotient rule combined with the power rule. Doesn't look like a lot of fun, does it? All right, you could pause here and come back if you want, because it's really not too bad. And it's completely different. So here we go. We got d of x, 4x minus 3 cubed over 4x plus 3. This time the 4x minus 1 cubed is our double. So we let y equal u cubed, and u equal 4x minus 1. Do our derivatives of each, multiply them together, replacing the u. So we end up with 12 4x minus 1 squared, derivative of the numerator. Okay, now we have to do our product rule. So we know we do the derivative of the numerator times the denominator, x plus 3, minus the derivative of the denominator, well, the derivative of x plus 3 is 1, times the numerator over denominator squared. Nothing different. Now let's look at what they have in common in the numerator. And they have an x minus 1 squared in common. So we're taking out the x minus 1. Probably should have put a bracket here to make this easier to see. So the x minus 1 squared is getting factored out. That leaves us 12 times x plus 3 on the first term, minus x minus 4 on the second term. Let's do our distribution. So 12x minus 4x is 8x. 36 plus 1 is 37. And we are finished. Okay, pause and try yours. Okay, I hope you did a good job. You should have recognized that the numerator was the one that was in trouble. So we did y equals u to the 7, u equals 3x plus 2, your derivative of the y, your derivative of the u, multiplied and replaced. And you got 21, 3x plus 2 to the 6, derivative of the numerator. So now we took the derivative of the numerator times the denominator minus the derivative of the denominator, which is just 1, times the numerator over denominator squared. Now we looked at this numerator up here. Look for what they have in common. So we're looking for the greatest common factor. That's what you're looking for. And it has 3x plus 2 to the 6th power and nothing else. So when we took out the 3x plus 2 to the 6th, so this guy's gone, we're left with 21 times x minus 1. Take out to the 6th power, and we have 3x plus 2 left, all over x minus 2 squared again. All we do now is distribute and combine, giving us 18x. Distribute and combine, so negative 21 minus 2, negative 23, and we are done. Not too bad. Okay, application. We have revenue from parking tickets collected at a given rate of Rn is 8n over n plus 2. So this is our revenue function and represents the number of working hours. Flu hits, or COVID, who knows what, number of working hours decreased by 6 hours a day. Before the outbreak, there were 30 working hours of patrol per day. How fast is revenue decreasing at the outbreak of the flu? Okay, to do this, we have to take the derivative of revenue with respect to time. All right, cannot do that at the beginning, so we do derivative revenue over dn, and then the derivative n over dt. Okay, what we do here, I can get this to move down for me. Okay, the derivative of r with respect to n is just 8,000, so the numerator times the denominator, minus the derivative of the denominator times the numerator over the denominator squared of r. Gives us this. We just used a straight quotient rule, nothing exciting. Okay, the derivative of n with respect to t. So how is n changing with time? This is actually from the reading. It said it was decreased by 6 hours per day. So that's not math, that's reading to figure out what you're doing. So my derivative of n with respect to time is decreasing by 6. So it's just negative 6. I hope you're good to this point. Now to find the derivative of r with respect to t, we multiply those two things together. Good here. I'm plugging in 30 because I want to know what 30 working hours for my n. And we get negative 93.75. So we are losing $94 a day because of the flu. Kind of cool, huh? All right, I hope you're doing well. Your turn. Okay, this one wasn't as bad as the last one. I hope you recognized how it was different. All right, I'm going to show you how to do the derivative, even though we have a u and a y, without using the u and the y. If you understand this, great. If not, go back to the old way. Okay, the way you do this is you take the exponent times the coefficient, so 500 times 120, leave the inside, which is your u, and you reduce its power by 1, so 119. Then what you're really doing is you're multiplying that by the derivative of u, which is 1 over 1200. So you can do this in one step if you understand. Let's try it again. Power times coefficient. Leave this, so leave your u alone, don't rewrite it, and reduce your power by 1. Times the derivative of the inside, or the derivative of u, which is 1 over 1200. When you do that math, 500 times 120 divided by 1200 is 50. So this is my derivative of r. Okay, now when you do that, I want to know what it was, this should have been if r equals 5. So we're going to plug 5 into this equation, and it's $82. So at 5 years, it is changing by $82 a month, which is kind of nice. I'm getting that much money at that point in time. All right, good luck with your homework. I hope you do well. Remember to post